Hello friends, in this session we are going to discuss about the Java language and its fundamentals. Today we will be concentrating more about the new feature of the Java. It's not the new feature, for the discussion it is the new feature that's called as garbage collection. In short, it can be called as GC. Okay, let's start writing the program for that and then we'll try to understand it. We have assume that we have a class called as box which has some variables. What kind of variables are they? There are instance variables. Okay, now int b, int h. There are three variables. Now I will be able to create three instances of this, right? I can create a number of instances of this. Basically I am trying to create an object of this. Box b is equal to new box. Box b1 is equal to new box. Box b2 is equal to new box. What has happened inside the memory? Three memory allocations has been created inside the JVM. Three memory allocations has been created, which has been referred by right now b, b1 and b2, right? Let us assume the addresses for this is 150, 250 and 350. So when I try to print out all these things, it is going to print you 150, 250 and 350. Correct, right? Now I should have not written here. Okay, now what I'll do is, let us try to print the things here. Okay, this is going to print you 150. For now it is going to print you 150 because it's pointing to the memory location called as 150. Remember, this is an hexadecimal number when you print it out. Okay, now it's 350. Now when I try to assign, it's just a variable, right? Although it's an object, it's just a variable. B is equal to b1. What happens here is, b1 instead of pointing to this, it starts pointing to this. Correct, right? Sorry, b instead of pointing to, right now b1 value 250 will be given to b. Instead of pointing to this, b will start pointing to this. Correct, right? Then I can also go ahead and say b2 is equal to b. What is the value of b right now? At this stage, b is equal to, it's not 150, it's 250. Value of 250 is given to b2, so b2 also becomes 250. So basically what has happened, instead of pointing to this, b2 will also start pointing to this memory location. If you see here, this object and the other object is still available in the JVM, right? Can I access these two objects? I will not be able to access the members of these two objects, but still they reside inside the JVM. Such kind of memory allocations are called as dereference memory allocations. They don't have any reference, but they reside inside the JVM. What we need to do in Java is, we need not to do anything. JVM will take care of everything. What it does is, at a certain point of time, garbage collector, there is a thread, there is a daemon thread inside the JVM called as garbage collector. That thread will be invoked by the JVM itself. Whenever this garbage collector thread is been invoked, it is going to look out for the dereference objects and then throw the dereference object from the memory. That's what it is going to do. Okay, now let's assume there is a dereference object available inside the memory. Okay, there is an object which is residing inside the memory and it has some reference. This object can communicate to database also. Correct, right? It will be able to communicate to database. So let's assume this is a database. It's a database. At certain point of time, I can go ahead and nullify this object also, or else due to some operation this variable will not be pointing to this object. So what happens, this object which is residing here becomes a dereference object. So when it becomes a dereference object, what would happen is garbage collector at some point of time, as a developer I don't have the handle to activate the garbage collector. It is the JVM which is going to decide when the garbage collector has to be invoked, when the garbage collector thread has to be called. Now whenever the garbage collector gets activated, the first thing it is going to look out for is the dereference object. Once the dereference object is found, it is going to throw it out from the JVM. That's what we understood. But assume that if it directly throws out, there might be a crash inside the JVM or inside the DB, because there is a connection between these two things. First thing what we need to do is we need to remove this connection, right? So what we need to do is some part of the cleanup code for the DB, or this example it's DB, but assume our object is connected to some remote server, or it is speaking to some remote client, or whatever it may be. It has some resources. Object would be having some resources which might be connected to something else altogether. So before this object has been destroyed, we need to clean up some code. So that cleanup code, where will you write? So that cleanup code can be written inside one method called as finalize method. So inside this finalize method, you can write some cleanup code. You can see in the JDBC classes and all how to write up the cleanup code in the later sessions. So what happens whenever the garbage collector gets activated, it is going to look out for the dereference object. If it finds a dereference object, the another thing it is going to do is it is going to look out for the finalize method. If you have given the finalize method, if you have overridden the finalize method in your class, the finalize method will be executed first. The finalize method would be executed first, and then the dereference object would be thrown outside the JVM. For now, you will not be able to execute the finalize method. You will not be able to execute the finalize method. Or you will not be able to see this finalization, because you don't have, as a developer, we don't have the handle to invoke the garbage collector. Although there is something called as system.gc which says we will be able to invoke the garbage collector, we will not be able to invoke we will not be sure when the garbage collector will be invoked. Okay, but whenever it gets invoked, first thing it is going to check is going to look out for the garbage collector. If it finds the garbage collector, then the other thing is it is going to figure out whether the finalize method is available. If it's there, then it is going to execute the finalize method, then throw the dereference object from the JVM. That's what it is going to do. Okay, the other thing right now is there are multiple ways of making the object to be eligible for garbage collection. One is just go ahead and say B is equal to null, some object is equal to null, then immediately this object will be dereferenced. Either B is equal to B1, something like previous one, instead of the object will be pointing to something else, immediately starts pointing to the newer object. Immediately what happens, the previous object would become dereference object. Thank you guys. If you like this video, please give a thumbs up and please do subscribe for the channel, and if there is any scope of improvement, please comment out the things below, and thanks a lot.